Good to go. You're good whenever you are.
Okay. Well, my name is Cassie Crawford, and our group is doing reasoning mathematically. My topics are inductive and deductive reasoning. Our learning objectives for this is to be able to define inductive and deductive and to work problems by using both types. Inductive is drawing conclusions based on evidence obtained from specific examples, and the conclusion drawn is called a generalization. Deductive reasoning is drawing necessary given information to arrive at a proof or solution to a problem. Here's an example of inductive reasoning, and the key to this is finding a pattern in your problem so you're able to solve it. And here's an example for deductive reasoning. And now we're going to move on to Mr. Scott, who will inform us on representational reasoning. Take the floor.
Okay. If you would, stop sharing your screen.
Okay.
Great. All right, you can see mine, correct?
Nope.
No.
All right.
Yes.
There it is.
Okay, great. So, thank you, Ms. Crawford. For knowledge of the indirect reasoning, I want to go ahead and just jump right into everything. I'm Mr. Scott, and let's get going. Any questions you have, don't be afraid to ask. I will answer any questions that I can. But I'm talking about representational reasoning. It's an internal way of seeing and thinking about mathematical ideas. Or I need to give a representation for my reasons of doing a certain thing a certain way. Words to remember that I will kind of show you symbol, picture, visualize, or to see, and then example. For mine, I chose to use PEDMIS because PEDMIS, you have to represent each of the things with the letters, which the letters are kind of like the symbols. PEMDAS, which is parentheses, exponents, multiplication or division, and addition or subtraction. This is just an order of how to do a mathematical equation. So now we have a simple one, 1 plus 2 times 3. And then since we have this, generally they teach you to work left to right. So if we work this left to right, you would do 1 plus 2 equals 3. So then you have 3 times 3 equals 9. And dealing with the order of operation, that would be the wrong answer. So I just give you an example of how to use PEDMIS the wrong way. Because it says to use, if you go back, it says to use multiplication and division first before addition and subtraction. So here's another example. And then this is the right way to do it. Here, they have the parentheses, exponents, and then going back to here, you start out with the parentheses, and then you move to the exponent. So in parentheses, you have 3 plus 4 equals 7. And then you have the parentheses, which it goes down to the next step. 7 squared equals 49. And then you multiply. So you have 2 times 49 equals 98. And then you come over to the subtraction. 127 minus 98 equals 29. And then that's how to use PEDMIS the right way. And then representation or reasoning, we just represented the operation with PEDMIS. And this is why we use it, so we can get the correct answer in operation form. Now we have Mr. Dufresne. Mr. Dufresne will come to us and he will talk to us about another kind of reasoning, which is, oh man, mathematical reasoning. There we go.
Okay. Good afternoon, class. I am going to be talking to you about mathematical statements. And here we go. Can everybody see my screen?
Yes.
Yes.
Okay, great. Okay, so we've talked so far about inductive reasoning and deductive reasoning and representational reasoning. So what I'm going to talk to you about is what is a mathematical statement. But before we do that, let's get this math machine rolling. And okay, what's a mathematical statement? Does anybody know what a mathematical statement is? Can anybody tell me anything? Okay,
Can't.
well, no idea. That's okay. We're going to figure it out. Here is the definition. A mathematical statement is a declarative statement that is either true or false, but it cannot be both. Real simple to think of that way. So we're saying something is this way, and that it's going to be either true or false. So, well, you say, okay, that doesn't tell me a whole lot. Well, let's look at some examples. Here's two mathematical statements. Yes, it's numbers and symbols, but it's still a statement. So if we were going to say this out, it'd be 2 plus 2 equals 4. This statement is true. We know that 2 plus 2 equals 4. One way to think of it, the statement, is a complete sentence. If it has an equal sign in there, it's a complete sentence. 2 plus 2 equals 4, complete sentence. Now, another example is 2 plus 3 equals 5. That's actually a true statement too, and I don't know why it says false on there, but it's a complete statement. Okay, I think I was going for something else in there and messed up on the slide, but that's all right. We're going to drive on with that. Okay, so with these mathematical statements, there's a couple of things we need to know about these, and we're going to go over some of the stuff with it. So we were going to combine some statements. One of the common ways to combine statements is to use the words and and or. So if we're going to do this, if P and Q are true, if both statements are true. So, and then we could say if P or Q are true, if either one of the statements are true. I know that doesn't make a lot of sense, but when we put that together into our operations, the way we say our statements, it'll make a little more sense. So, and then we have what we call conditional statements. Now, conditional statements are our statements that include the words if and then. An example I have down here, if x equals 2, then y equals 4. That's one way of stating it, or one of the operations we may be doing, but that is a mathematical statement right there. It's a conditional statement. This equals this, then this must equal that. Does that make sense? Is everybody following so far?
Yes, sir.
Okay. Some of the components of our mathematical statements are equations and expressions. Okay, we'll get this. I apologize, guys. It's the first time using this new format. I'm using a Prezi instead of a PowerPoint.
You're doing great.
We're going to get through this. Okay, if we look, one way to look at this, and I've brought this up before, if we look at math as a language like English, then mathematical statements are sentences that are either true or false. Expressions are parts of the sentence, like sentence fragments, right? We take certain sections of sentences and put them together, and that makes complete sense. Well, that's what the expressions are. They're pieces of it. Once we put the equal sign in there, and then something on the other side, that's what's going to give us our complete sentence. Does that make sense? So,
yes,
equations are a complete sentence. Expressions are the fragments, and that's what are mathematical statements. Also, we have the conditions, the if and then. We can combine some statements for the ands and ors. So, in a nutshell, mathematical statements are how we talk in math. That's how we speak the language. So, but there are very specific rules to it. Remember, a declarative statement that is either true or false, but not both. Okay, that's the one thing I want you to take away from this.
Right.
And the other part of this Is it equations and expressions? Those are what make up our sentences. Okay. We learned about today class, we learned about inductive reasoning, deductive reasoning, representational reasoning. That gives us a view of something we want to see how it works. And then I talked to you about mathematical statements. Hopefully you've taken away a little bit from some of this, and you're going to be a lot better at rolling that math machine down the road. Thank you very much. Have a great day.